welcome back to scientific terminology. Today we are going to be talking about atoms and what they do. And I describe them as the building blocks of the universe. So let's get started. First of all, atoms are just the smallest individual part of matter that retains physical properties. So they're the smallest possible piece of anything that you could find that has the same properties as that thing. So for instance, oxygen is an element, which means that the physical properties of oxygen are all sorts of different things, right? But if you go any smaller than an oxygen atom, you lose those properties. So that's what that means. There are currently 120 types of atoms, and those are called elements. And atoms are made up of smaller subatomic particles, some of which we have not even discovered yet. We're still looking for them, but we know that they're supposed to be there, but we don't know what they all are yet. And then the three main components of atoms that we're going to talk about today are protons, neutrons, and electrons. So the structure of an atom has kind of evolved over time as we've learned more about it. But for the basics are that atoms have a nucleus that contains the majority of its mass. And that nucleus has the protons and the neutrons in it. Now surrounding the nucleus in different energy orbitals are electrons, and those electrons aren't very heavy. Their mass is negligible compared to the protons and neutrons, meaning they're really small. And they float around the nucleus going really fast at the speed of light. And most of the atom is just empty space. So the electrons are moving really fast, and they can only really appear in certain areas due to the amount of energy they have. Now to talk about the subatomic particles more, protons are positively charged, and they're in the nucleus, like I said, and they have a mass of about 1 atomic mass unit, which is a special unit that we use when we talk about subatomic particles. The number of protons determines what element the atom is. So, right, hydrogen has 1 proton in it, so it's hydrogen. 2 protons, it's helium, and so on. Neutrons are neutrally charged, and they also inhabit the nucleus. They have a mass around 1 AMU as well, and different atoms of the same element can have different number of neutrons. And when that happens, those are called isotopes. So for instance, a hydrogen atom could have 2 neutrons, or 3 neutrons, or 1 neutron. Those are all different isotopes of hydrogen. They're still hydrogen because they have the same number of protons, but they're going to have different masses because they have different numbers of neutrons in them. Finally, the electrons are negatively charged, and they're not in the nucleus. And they have a lot less mass, and they're limited to where they can go based on really strict rules that have to do with the energy level of the electrons. Electrons can come and go from the atom as they kind of please, so they determine the charge of atoms. So electrons can leave or come based on a number of factors. There are other subatomic particles besides these 3, but when we talk about the basics, we generally just deal with those 3 subatomic particles. Determining what they are and what they do has been one of the really big questions concerning physicists. And the most recent particle to be discovered was the Higgs boson particle. And this boson particle explains why some particles have mass and others don't. The particle was predicted to exist in the 60s, but was not actually confirmed to exist until 2012, when we actually detected one inside the Hadron Collider at CERN in Switzerland, which is a really big research laboratory near Geneva. Its discovery updated the standard model of particle physics and moved physicists one step closer to the universal model of natural phenomena, which is kind of this big, overarching model that explains every physical phenomena in physics. Just to talk about the standard model a little bit, the standard model of particle physics is so important because it explains 3 of the 4 fundamental forces. We still haven't figured out how to put the 4th one in there yet. But those forces are electromagnetic forces, the weak force, and the strong force. So those 3 of the 4 major forces can be explained because of the standard model, which is pretty important. Moving back to atoms, though, they're important because all matter is made up of these incredibly small parts. So understanding what they do and how they interact is incredibly important to understand other phenomena in our universe. Chemistry is the branch of science that really studies the interactions of these elements and how they are used to build all of matter. Meanwhile, physics examines the interactions between the different parts of the atom. And as our understanding of atoms has evolved, the scientific community has been able to make great progress in things like medicine and material chemistry and pharmacology and energy and countless other areas of importance. Thank you so much for watching this science terminology video about atoms, and I hope you've learned something and you're ready to come back and learn more next time. See you later.